Hello, this is Owen again. I'm going to talk about how I did the lift on this robot. So let's just point this towards the lift. So right here, it's powered by two 393s. These are torque motors. They're in the torque gear configuration. They power this metal pinion, which powers this big gear. So this is a 5-to-1 gear ratio. It will rotate. This small gear goes around 5 times for each one rotation of this big gear, which is, it gives you some more torque. It's 5 times more torque than just a direct driven motor, and I think it's a pretty good lift gear ratio if you don't need to lift too much weight. If you need to lift more weight, I would go 1 to 7, which would be the next size gear up from this. But let's rotate this around. So this is a 6-bar lift. It has, let's move that so you can see it better. Only this bottom bar is powered. This is the only bar that's hooked up to a gear. But then it transfers the power through this linkage. So the whole thing goes up like that. And this part at the end stays straight, because it's how the linkage works. Now, a 4-bar linkage is similar to this. You can just have this bar continue and then be attached here. But then the 6-bar gives you more height, because instead of being attached here, it's instead attached here. So otherwise it would be about that much lower. Now, you can also extend this further by having another part that goes up there and across here, and then it would be that much higher, and that's an 8-bar, and you can continue it more and more. But each time you continue it, you need more joints, which adds more weight and decreases in efficiency. Now, for your joints, you want to have bearings on all of them and run screws through them and use nylock nuts. Now, you want to use nylock nuts because your screws need to be a little bit loose to be able to run the lift with minimal friction, and friction will again reduce its efficiency. So you want to have these be a little bit loose, and then if they're nylock, they'll stay on. If they're keps, they'll just fall off if they're loose. Now, I also have a bar across the top here, which does two things. It makes the lift a lot more stable, so there's very little flex in it. This is me trying pretty hard to flex this lift, and it doesn't flex all that much. And it also holds these rubber bands, and these rubber bands are very important. Good rubber banding can make the difference between a good robot and a bad robot. So how these ones work is they go down over here and then over the back of the lift here and attach here. So I've done a lot of different work with rubber bands. One of the easiest places you can attach them is if you just take some, if you put like a standoff here and then a standoff here, you can put rubber bands between there and it will hold it up, and it will help your lift out. But I've done a lot of work with rubber bands in different ways on different robots. I think this works really well because it's pretty, it stays the same force more or less wherever you have it. This isn't completely true, but it's about right. The problem is they break. Like, I think one just broke right now, but you can always replace them. I'd recommend getting a 1-pound bag of rubber bands, number 32 rubber bands, which is legal and a lot cheaper. And then you can just replace them with no worries. So what this does is it pulls it straight up there, then as it goes down, this goes out, so it both has force pulling back up here and force pushing down right here, which both help you lift out. Now, if you're trying to hang, you might want to have rubber bands to help it go down instead of go up, or no rubber bands. But this is just for having it assist going up. I hope this helps. Thanks. Bye.